Hello everyone, today we're going to be working on example 6-5 and this example is asking us to identify the zero force members for the trusses given below. So I'm going to start off with the truss on our left side. So before we start identifying any zero force members, the first thing we have to do is first see where we have some reactions because the reactions will take to play helping us identify those zero force members. So we don't really have to determine the direction of the reactions. We just got to determine where a reaction will be. So at point A, we have what seems to be or is a roller support, meaning that we're going to have one reaction, which is vertical. So right here we have our roller on this platform or wall. So we know that there's going to be a vertical reaction. I'm just going to draw it going to downwards or to the right to us. Once again, the direction does not matter, but we do know that there will be a reaction at that joint right there. Now for our uh, B, our point B, we have a pin support, meaning that we're going to have two reactions, the vertical and horizontal reaction. Once again, it does not really matter which direction it's going to be going or reacting, but we know that there's going to be two reactions at that joint or that point. So I'm just going to, once again, draw it going outwards, but we know we have this horizontal reaction in our view and this vertical reaction. Okay, now that we determined these three extra, not extra, these three reactions because of the supports that this truss has, now we can start identifying those zero force members. So remember, there are two cases when it comes to identifying zero force members. The first one is where only two members meet at a joint at an angle other than 180. So it cannot be 180, it could be less. And no external force or support reactions exist at that joint. And if there are only those two members at a joint, not 180 degrees, then both of those members will have a force of zero. The second case is is also referred to as the windshield wiper case, and that's basically when there are when three members meet at a joint. Two of them are collinear, and one of them are non-collinear. So then the non-collinear one would have a zero force reaction. So remember, first case, two members not in 180. It's just those either two members, no reactions, nothing else. Both of them zero force members. The third one, it could be it's three members, two of them collinear. The non-collinear one will have the zero force member. So I'm going to start off, and right away, the first thing that catches my eye is joint C. Because as you guys could see, if we were to take joint C, we have one, two, three members right there. Okay, since it has three members, I know that case two is the only one with the three members. Okay, now from there, case two, what does it say? Two of them have to be um, linear, collinear to each other, and one of them has to be non-collinear. As you could see, the member CD and BC are collinear to each other. And then we have AC, which is non-collinear to them. So that means right away, this one has a zero force member. Okay, so we're going to write that down. The first one is at joint C. We have a case 2, making the force of the member AC equal to 0. Now from there, another joint that we could look at is joint A. So once you have determined that a member has a zero force member, So in this case, joint A, now we're looking at joint A. When now that we know that this member has a zero force member, when now looking at joint A, we no longer include it in the joint since we know that has a zero force member. So if I were to draw out joint A now knowing that member AC is a zero force member, this is practically what I would be looking at. Our reaction, our member AD, and our member, what is that? AB. I no longer have this member AC because I know that it has a zero force member. Now, if I would have started with joint A before doing joint C, then yes, I would have to draw it out because I still don't know that it was a zero force member. But since I started off at joint C and determined that it has a zero force member, now looking at joint A, we're only now dealing with three members. So now looking at joint A, seeing that there's three members, once again, we could have that case two. But remember, two of them have to be collinear and one of them non-collinear. As you guys could see, our reaction and our member AD are collinear to each other. And then we have our member AB, which is non-collinear to both of these two, meaning then that our member AB would have a zero force member. So then from there, um, those are all of the zero force members. Because remember, case one only allows us to have two members that meet at a joint. There's no other reactions, no other members. And if those two members are at an angle other than 180, then both of those two will have a zero force members. So if we were to look at the other joints quickly, joint D, we have one, two, three. Okay, there's three members, three forces there. But remember, case two is the only one that deals with three forces or three members. Two of them have to be collinear, which we could see here that none of them are collinear to each other. So already we know that these ones will have forces to them. Joint A, we already did. Joint C, we already did. So the last one would be joint B. At joint B, we have two reactions and two members. So right away, it cannot fall in case one or case two. So these were all of the zero force members. So our second one that we found was at joint A, we had once again a case two making the force of the member AB having a zero force member. So with that, we are done identifying the zero force members in the on with the truss on the left side. Now we're going to proceed and work with the truss on the right side real quick. Okay. So remember, the first step is determining reactions because as you guys could see, the reactions came in play. So here we have at point B, we have a roller support, meaning that we're going to have one reaction. Once again, it doesn't really matter the direction of it, just is there a reaction there or not? There will be that vertical reaction. I'm just going to put here that it is going upwards, but once again, it does not matter. From there, we have one more place where we could have a reaction, which is point D, where we have a pin support, meaning we're going to have two reactions. So I'm going to draw those in. There we go. So now that we have that, now I'm going to start determining or identifying those zero force members. Right away, I could see that at joint B, we have one, two, three members, right? Our one reaction, our two members. And then right away, I could see that our reaction and our member BC are collinear to each other. And then we have our member AB non-collinear to them, making this member a zero force member, right? So I'm going to quickly write that down. At joint B, we have once again a case two, making the force of the member AB equals 0. So remember, now that we know that this is 0, now in the future, we will not draw it out or take it into consideration to other joints. So with saying that, now my eye catches joint A. Because why do I say that? Because we have this force right here, we have this member and this member. Yes, AB was a member, but since we did joint B, we were able to determine it has a zero force member, so it will no longer come into play at joint A. So technically now we just have 1, 2, 3 members. And as you guys could see, this force of 800 pounds and the member of AD are collinear to each other. And then our non-collinear member would be the member AC. So once again, we have a case 2 making member AC a zero force member. So this is our second one. At joint A, we have a case 2 making the force of the member AC equals 0. Okay, now remember, now that we know that this member has a zero force member, it will no longer come into play in future joints. With saying that, now I could move on to joint C. We have 3 forces, 3 members. We have our force of 200 pounds, we have our member CD, and then we have our member BC. As you guys could see, once again, our 200-pound force and our member CD are collinear to each other. And then we have our member BC, which is non-collinear to them. Hence, once again, a case 2 making the member BC equal to 0, having a 0 force. So at joint C, once again, we have a case 2 making the force of the member BC equals 0. So now that should be all the zero force members, but now I'm just gonna quickly check. If I were to go to joint D, we have 1, 2, 3, 4. And remember, none of our cases deal with 4 members, 4 reactions, 4 forces. So we know automatically there is no other cases that we could identify there. And then if I were to go back to the joints that I already worked with, from there we have a joint A. Now we're dealing with 1 and 2. So it would have to fall under the case 1. But remember, case 1 specifies that it has to be 2 members meeting at a joint. And here we have a member and a force. So right away, it does not meet that. And then plus it has to say that both of those members have to meet at a joint at an angle other than 180. And you guys could tell that, like we mentioned before, these two are collinear to each other, meaning that they have a 180-degree angle. So no, at point or joint B, we know that this is a zero force member, this is a zero force member. So now we just have the reaction. So just one force there. It doesn't fall into any of the cases. And then joint C, looking back at it now, we know zero force member, zero force member. So we would just have the force and the member. Once again, case 1 deals with 2 members. It has to be 2 members. Here we have 1 force, 1 member. So right away, no. Either way, it has a 180-degree angle. And remember, it says that it has to be, those 2 members have to meet at that joint of an angle other than 180. So with that, we are done identifying the zero force members of the trusses given below. So once again, when you want to identify the zero force members of a truss, the first thing that you want to do is determine where there are reactions, because those do come into play. And then after determining where the reactions are, remember, it does not matter the direction, just simply draw them out. And then from there, start identifying those zero force members of any trust given to you guys. Thank you guys so much for watching this video. Please feel free to give this video a thumbs up if you found this video helpful, and also feel free to subscribe to our channel if you guys would like to see more videos like this one.